Okay, one more video to get through this titration here. We're still titrating acetic acid with sodium hydroxide, but this time we're going to push right through the equivalence point, and we're going to go and see what happens to the pH after the equivalence point. Again, our comparison here to a strong acid and a strong base, which starts at 1, comes through an equivalence point at pH 7, and then up to a pH close to 14. With the weak acid, what we found out was that it actually trails up to higher pHs first, and then pushes through an equivalence point that's above 7. It turned out to be 8.2. But what we're going to find is, on the other end of this graph, this is going to behave the same as a normal strong acid, strong base situation, because it will be the strong base that's taking over. So here we're in situation 3. 20 milliliters of acetic acid, CH3, COOH, reacting with NaOH to produce Na+, H2O, and CH3COO-. So there we have all our species. Now, we always assume that our acid-base reaction, when we have a real acid and a real base, not just water, goes to completion. So here we have 0.2 molar CH3COOH, and we have a volume of 0.02 liters, or 20 milliliters. And here we have a concentration of 0.1 molar NaOH, and we have a volume of 60 milliliters, or 0.06 liters. C equals N over V, so N equals CV. So we're going to go to moles here because this is not an equilibrium reaction, but instead a reaction happening to completion. So for moles of acetic acid, we're going to get 0.02 times 0.2, or moles of 0.004. And for NaOH, we're going to get 0.1 times or 0.06, or 0.006 moles. What we see now, because we pushed past our equivalence, is that our original acid is the limiting reagent. It's going to react away completely, and remaining after the acid-base reaction is going to be 0.002 moles of sodium hydroxide. We're going to create a bunch of stuff over here, including 0.004 moles of acetate, but because we have strong base remaining, the actual effect of all these other things is going to be very small, so this is really the only thing we care about here. Our concentration of NaOH after the reaction is going to be moles on volume, which is 0.002 moles divided by a new total volume of 0.08 liters. And I get 0.025 molar sodium hydroxide. And with sodium hydroxide, because it's a strong base, where that minus came from, we assume that it completely associates to become sodium and hydroxide. So if I have 0.025 molar sodium hydroxide, I get 0.025 molar hydroxide, and I don't have to do any equilibrium stuff. So I can go straight to my pOH then, which is going to be negative log of hydroxide concentration, which will be log that, negative 1.6. And then I can use my relationship between, positive 1.6. And then I can use my relationship between pH and pOH, totaling to 14, to come up with my pH, which works out to be 12.4. So as expected here, the strong acid, or the strong base, once it's neutralized that weak acid, it takes over the situation, and as it does, typically behaving as a strong base, it drives the pH way up close to 14. So we blast right through this equivalence point and come right up to this high-end pH, just like we would have done if we had a normal titration between a strong acid and a strong base. So here we saw the pH come up to 4.7 before equivalence, seeing that the pH varies a lot more when a weak acid is titrated with a strong base. The equivalence point turned out to be well past 7, as the anion produced at equivalence was able to change the pH of the solution. And then finally, once the strong base took over, the pH swung right past and came very close, very up to 14, which is a strong base, or a pH we associate with a strong base. So that's what happens in the titration of weak acid. I'm going to do this again from a base perspective, and you can check out those videos.